want to now look at how can we find expected value of continuous random. So we want to look at expected value of continuous random variable. Right, so for this, we know expected value of x is given to us as the integral from minus infinity to infinity x fx dx, where fxx is a PDF of x. Now, let's just quickly recall that if x was discrete, this is something we've looked at already. Expected value of x would have been summation over all x pxx. Right, where pxx is a PMF of x. So if x is discrete, then we use summations. If x is continuous, we use integrals. So, and similarly, we know how to find expected value of a function of the random variable x, because the function random variable is also a random variable. So here, now when you want to find expected value function random variable instead of x, we have gxa, but we still have fx of x here, dx. We're still using the PDF of x, right? So the idea over here is this. So we want to find the expected value of this function. So we use gxa, but we still have fx of x here, right? So we still have fx of x here, right? Right, so the idea is this over here. What we're doing is we are replace x with gx, but still replace x with gx, but still, so we replace x by gx, but still work with PDF of x. Right, so you don't need, the idea behind this is something we discussed when looking at expected value function discrete random variable as well. So you don't need the PDF of x. Sorry, you don't need the PDF of gx to find its expected value. All you need is the PDF of x to find its expected value. All you need is PDF of x. Right, because remember, if x is a random variable, function of a random variable is also a random variable, right? So if x is a random variable, gx is also a random variable. A function of a random variable is also a random variable, right? So if you want to find expected value function continuous random variable, you can do it like this, right? You just replace x with gx, but you're still using the PDF of x. So you don't need the PDF of this function of random variable gx to find its expected value, because one option could be use its PDF, right? We find out what the PDF of g, because see, like gx could be, for example, say x cubed, right? So what we do is we find the PDF of x cubed, like, we can name this y, so y is x cubed. And then we find the expected value y using the PDF of y, right? So we find the PDF of y, which is x cubed, and then find its expected value using its PDF, but you don't need to do that. If you're finding the expected value of any function of discrete or continuous random variables, you can find the expected values using just the PDF of x. Right, that's the idea, because here we just replace with xgx, but we're still using the PDF of x, right? And if x was discrete, this would be written as if x was discrete. Then this would be given to us as expected value g of x, but instead of integral, remember we had a solution. So again, we replace x with gx, but we're still using the PMF of x, right? So whenever you're finding expected value function, discrete or continuous random variable, you can always find expected value of the function using the PDF of the original random variable. You don't need the PDF or PMF of the function.